I got a call from one of my customers. He was getting multiple trouble tickets concerning a productivity suite they were using. I asked if it was a slow or no situation. He told me the tickets were about slowdowns and he could ping it just fine. Could I help him? We'll need the packets to know for sure. I logged into the company's EndaceProbe after getting some details. Time, application, and which client IP address logged the most tickets. The percentage of OneDrive traffic is higher than anything else, and that's our focus. The retransmission counts are high, which might be a cause and effect for the slowdowns. Could be a physical problem somewhere, but since the percentages are low for all but one subnet, I don't think the issue lies on my customer's side. Let's download these packets to Wireshark so we can see if it's just standard packet loss or something else. The user complaints were about waiting for downloads, so let's look at a worst-case scenario and see if there's a pattern. It looks like high delay for both the standard server response packets and retransmissions. Hey, they all have a TCP bytes in flight of 1460. That's a full-size packet. That is an interesting pattern. Bytes in flight are those that are sent but not yet acknowledged. We'll mark the worst examples so we can see them in context. So the server retransmitted a packet. We can see the original transmission and the acknowledgement that was sent. But even if that ACK was eaten by the internet, why is the delta so high? The server should have retransmitted much closer to the round trip time. And this pattern shows itself again, and again, and again. But the retransmissions weren't the only clue. Notice the high delta at the beginning of an application block transfer? The app is taking seconds to start sending the next block to TCP. I wonder how much latency this causes in the whole transfer. Let's take a look. Well, that answers that. Some of the delay belongs to the server's TCP stack taking too long to retransmit, and some belongs to the application taking way too long to get started with a new block. 2-for-1s are the best. We just went from searching across terabytes of data to finding an exact example of the issue pretty quickly. From there, it was easy to see what the causes were and where the blame lies. Another packet mystery solved. My customer was glad his network was exonerated, and his users can now start talking to their cloud provider about service level agreements, armed with some ironclad evidence. Do you have a packet mystery you'd like me to solve? Tell me about it in the comments below, and maybe it will inspire the next installment of Packet Detectives.